All right, so number 17 on page 329 says this. In a study of speed dating conducted by Columbia University, male subjects were asked to rate the attractiveness of their female dates. Okay, I'm already there. All right, and the sample of the results is listed below. Oh, I'm so sorry. One is not attractive, 10 is extremely attractive. Please don't do this. All right, now, use a 99% confidence interval. What do the results tell you about the mean attractiveness ratings made by the population of all adult females? Now, what I would have said, first of all, on a test, I would literally have said, construct a 99% confidence interval estimate. All right, so I'm going to make sure that it's worded to me better. Is everybody with me? So I would say construct a 99% confidence interval estimate for the mean attractiveness, or however they phrase it. Okay, so I'm going to make sure on the test that the problems are worded very carefully. All right. Now, as soon as it says construct a confidence interval estimate, it's going to be to your advantage to underline of what? So what am I doing a confidence interval for? What does it say for what? For the mean. Because as soon as it says do a confidence interval, I've got two choices. I'm either going to have P between two blanks, or I'm going to have me between two blanks. Okay, so we're only going to do confidence intervals for mean and for proportion. I'd love to do them for standard deviation, but this semester is just kind of tight, like we were talking about. Got some things that had to get cut. Okay, so how do I know which of these two to write on my paper? It's what I underline. Now, I want the confidence interval for mean. So which one of these two is the mean, the top one or the bottom one? What? The bottom one. So I automatically know on my paper to go ahead and write mu is between two numbers. Now, if it said construct a confidence interval for the proportion of people, I would know to grab this top one. Or if it said construct a confidence interval for the percentage of people, I would grab the top one. So that's why when it's a confidence interval, if you'll underline for what, you'll know which of these two formulas to grab. All right, so I've got my formula ready. Now, the calculator does almost all the work. Now I'm going to kind of do it and show you something. And I'm going to have to back up. All right, where do we go for confidence interval for mean? We have two choices. What are our two choices we're looking for? Is it one prop z int? Is that one of our choices? What is it when we're looking for a confidence interval for mean? What are our two choices? Yeah, look at your notes from last time. It's z interval and what? T interval. That's my two choices. All right, so I'm going to try to decide between z interval and t interval. Now remind me, you have to look back in your notes, look back in your notes. How do I decide whether to go to z interval or t interval on this calculator? Depends on the standard deviation. All right, so if I know sigma, now what is that? That's the standard deviation for a what? Population. If I'm given that, I go to z. If I know s, which is the standard deviation for a sample, then I go to t. Now, what's my problem? I don't have any what? Standard deviation. I don't go, oh my goodness, I don't have a standard deviation at all. Well, then you're going to have to go get one. Now, you did this on test 1, did you not? So remind me how I get a standard deviation when I've got a list of numbers. What do I do with that list of numbers? Don't you have to don't you have to go to stat and enter that data into a list? All right, so go do that first. All right, so go to stat, you're under edit, and enter that data in a list. I can turn my machine on, that would be good. Now I've already got some numbers in a list that I have to clear out. So you have to go back in your notes and remember, I had to up arrow to L1 and hit clear. And it just blinks at me, which means, are you sure? I'm like, yeah, I really do want you to clear it. So I have to hit enter. So then I come down and I'm gonna enter all my data on 17. So I'm gonna enter a 7 and an 8 and so forth. Okay, we got them all entered. Now, mine at the bottom says L1 in parentheses 13. That means it's waiting for you to type in number 13, which means I must have entered how many pieces already? 12. So I'm gonna go double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12. So I didn't skip one. Now, if it were a test, I would scroll back and double check and make sure I entered them all right. Okay? So now my data is in my list. Remind me, how do I get the standard deviation? I go back to stat. What do I go over to now? Calc. Okay? And then I'm on one variable stats, and I hit enter. And tell it where you put the numbers. I put mine in list 1. So I've got to do second 1 and hit enter. And then all this data comes up. Now, what is my standard deviation according to that? What's your standard deviation? Now, am I going to pick SX or am I going to pick sigma X? Because they're both there. Because if you pick the wrong one on your test, I'm not going to give you credit for it. Okay? Were these numbers from a sample or were these numbers from the whole, all the population? What were these numbers from? A sample, so you better pick SX. All right. So I'm going to write down that my standard deviation is about maybe 2.216 or something. Just round it somewhere. Let me see where you rounded it. Okay. Now, by the way, what's the mean? What'd y'all get for the mean on yours? You get 7? Because I want to make sure, is that about what you got in your standard deviation? Because I may have typed mine in wrong, so I need to double check. Now, by the way, it tells you a lot of other information there if you want to scroll down. But I know I'm going to need both of these to finish this. So we decided that this that this 2.216 is the standard deviation from a what? From a sample, you told me. So what are we going to go back and use? We're going to go back and use our what? Our T interval. All right, so let's go back. We're going to go to stats. All right, I'm going over to test and I'm going to come down to T interval and hit enter. Now, on a test, what I would expect you to tell me is this. I would expect you to tell me that you're choosing T interval. This is part of your scratch work if you want partial credit. So tell me whether you're using Z interval or T interval. And then it wants X bar, it wants SX, it wants N, and it wants C level. And I need you to tell me what you typed in. Now let me show you something. Look what's already on your machine. What's already on your machine? On mine, it's already that stuff over there. Is everybody with me? Most of yours will default to what's in a list, which would save me typing. Is everybody with me? But this is me being OCD. You can go over to data and it'll do it for you, but I'm going to go over to stats and I'm going to double check it because I don't trust the machine because I tend to do glitches. 7's already there. Now, I rounded over there. Isn't the unrounded, in other words, a better one? I'm going to leave it. But if you leave it, you need to write all that out here. If you want to clear that one and type in your rounded one, you can, but then do that. In other words, I'm not going to be happy if you tell me that you typed that in and the answer doesn't match for that. So either if it defaults, leave it like that, or clear it out and type that in. And I'm going to clear it out and type it in my machine because we're going to make sure our answers match. Okay. Now, I double checked. It had defaulted to 12, and sure enough, there were 12 in my list. Now, what confidence level did this one want? Not 95, but what? 99. So I've got to fix that. And I hit calculate. And the numbers that come up in the parentheses are the ones that go in the blanks. So did you get 5.0135 and 8.9865. Is that what y'all got? And that's my answer. Okay, so if that caused you trouble last night, is that a little bit better? Are we okay? So it's just going back and doing something that you know how to do. You know how to find mean and standard deviation when you have a list. Are we okay? All right, does anybody have a question about sample size homework? Or was that okay? Go back and look. Usually the only thing you're missing is the Z-score.
Did you do number 31?
Which page? Is it that same set?
It's
Like 331?
314.
314. All right, look at 314. All right, so 314, and which one was it? 31?
Yes.
Okay. All right. So we're on page 314, and we're doing number 31. All right, here's what 31 says. It says lefties. It says find the sample size needed to estimate the percentage of California residents who are left-handed. Use a margin of error of 3 percentage points and use a confidence level of 99%. A says assume that P hat and Q hat are unknown. Now, there are 2 different formulas. There are 3 formulas for sample size on your formula sheet. Look on your formula sheet. All right, I want you to tell me, because I don't have my formula sheet. All right. Now, there's one, what's the first one say? Is the first one proportion percentage? All right, now, on proportion percentage, there are 2 different formulas. All right, one says this, Z sub alpha divided by 2. Isn't this thing squared? And then it's got a P hat and a Q hat, and then that over an E squared. Then the other one on your formula sheet says that N, and it's got a Z sub alpha divided by 2 squared. Then it's just got 0.25 and it's over E squared. Aren't those the 2 formulas that deal with proportion and percentage? Okay, then you've got another formula that says mean. And it looks like this. N is Z sub alpha divided by 2. Don't you have a sigma over an E? Isn't the whole thing squared? Now, I did those from memory, so double check and make sure they're right. So as soon as it says find a sample size, or as soon as it says how many must you survey, or how many must you sample, I know it's sample size. Now go back and look in that word problem. Does it say the word mean anywhere in number 31? It doesn't, does it? So it can't be sample size about me. So that deletes that one. So now I've narrowed it down to either this one or what? Or this one. Now, we always use this one when we can, but for me to use this one, I have to know P hat. And what does A say? You don't know P hat. So when I don't know P hat, I'm going to have to use what? That one. So it's kind of process of elimination. All right, so I know to copy that formula down from my formula sheet. Now, where do you get the Z-score from? From the what? Formula sheet. So your Z-score is on the bottom right of that formula sheet. Now, what confidence level was 31? It said a confidence level of what? 99%. So you've got the formula sheet. What's the Z-score for a confidence of 99%? 2.575. But what does the formula tell me to do with that number? Just square. So I just copy it off the formula sheet. Then I've got this 0.25. Now, what does E stand for? Error. It doesn't tell me how much error they're going to allow me to have. What did it say? How much error? Does it say 3 points? It says 3 percentage points. So what's E? 0.03. Now, if it had just said 3 points, E would be 3. So I've got to read it very carefully. Now, I'm thinking order of operations. Do I multiply or do exponents? Which one comes first? Exponents. All right. So I'm gonna have to take that 2 point, if I can get right, 2.575 and square it. I'm kind of showing more steps, but on a test, I would show all my steps. Because the more steps I see, the more partial credit you can get if you make a careless error. Okay, so I'll multiply that numerator out. I'm gonna get another long decimal number, and you double check and you punch it on your machine to make sure I copied it down right. And then I'm gonna divide those two. And I got 1841.840278. See if that's what you got. Is that what y'all got? Now, you need to write yourself a note and star it. How do we round on sample size? Always up, because this is the minimum and you can't drop below the minimum. So I'm going to sample 1,840 what? 2. Even if this had been a 0, I still would have rounded to 1842. So we're not rounding off, we're rounding what? Up. All right, now look at the B part. The B part says, assume that based on a prior study, about 10% of Californians are left-handed. So do we understand now on B, I'm going to use this formula. Why am I going to use this formula on B? Because now I know what? P hat. What is P hat? Isn't that the proportion of your sample that does something? And what proportion did they say were left-handed? What did it say, 10%? So what's P hat going to be? Point what? 0.1 or 0.10 if you like, I don't care. How do you find Q's when you know P's? Subtract from 1. So what's 1 minus 0.1 or 0.10? Point what? 9 or 90. Do the same thing. E is error, isn't it? And you said our error was 0.00, I mean 0.03, it was 3 percentage points. But again, I've got to what? Square it. It's still a 99% confidence interval. So my Z-score is still a 2.575. But again, I've got to square it. Now again, if it were a test, I'd probably show way more steps, but I already got those shown kind of over here. So I'm going to multiply that squared number by 0.1 or 0.10, and then multiply that by 0.1, about 0.9. So I'm going to get this number, and you double check and make sure that you get the same one. And this time when I divide, I get 663.0625. Am I going to round that to 663? What am I going to round it to? 66 what? 4, because we're rounding up. Now I want you to notice something. When you knew a P hat, you only had to sample 664 people. But when you didn't know P hat, you see it jumped up to almost 2,000. Because if you don't know a P hat, you have to err on way too many. So what you're really doing, like we said in class last time, is you're letting P hat be 0.5. But when you know a P hat, your sample size is always able to be smaller and still be valid. And the mean formula works the same way. The formula is just different. But you were just still looking, your Z-score is going to be on your formulas. All right, everybody feel okay about that? Good. All right, now let's kind of do a real quick, because I left something off of an outline yesterday. So if you're on Zoom, make sure you go back and fix this. Okay. Your third test is going to be on chapters 6, 7, and 8. Okay, that we go over. So in chapter 6, it can ask you 2 questions. And I left off that second question yesterday. So I want you to go ahead and write it down. All right. It's going to ask you to find a probability and you got 2 choices. It's either a regular normal distribution, what we talked about at the pop test, or it's going to be central limit. All right, and you remind me how I decide whether it's normal distribution or central limit. How many of you picking on normal distribution? One. How many of you picking on central limit? More than one. So when it's central limit, what's the one extra thing that you changed? You changed your standard deviation. Then you went back on both of these to normal CDF. And remember, it was expecting 4 things in that parenthesis, which you can look up. Your left endpoint, your right endpoint, your mean, and your standard deviation. Okay? Just don't forget on central limit to change the standard deviation first. All right? The other thing it could ask you, which kind of got left off last time, is it might ask you to find a value. I'm going to put on a normal distribution. And it would be something like IQs are normally distributed with a mean of 100 and a standard deviation of 15. What IQ score separates the top 15% from the rest? Okay, so go back, you had homework on that. So remember on that, that's where you were doing inverse norm. And remember then it wants 3 things. You can go back and look at those 3. This first one was the area to the left. You have to have the area shaded to the left of the value that you're looking for, and then mean and standard deviation. We okay? Then in chapter 7 that we just finished, there are 2 questions. It might tell you to construct a confidence interval. And again, it might say proportion percent. And if it does, that's your P between 2 blanks. Or it might ask you to construct a confidence interval for me. And if that's it, it's going to be mu between 2 blanks. Okay? When it's proportion percent, remember that's when you went to 1 prop z int. Do you remember that? And when it's mean, we just talked about it's either z interval or it's what? T interval. And it's z interval when you know sigma, and it's t interval when you know s. Okay? Then the other thing it asked you to find was if you might be asked to find sample size. And again, there are 2 possibilities. It could be proportion percent, or it could be mean. And we just did the proportion percent. And make sure on sample size that you round up. So this is the way that Dr. Dan does it. Every time I take a test, I'm going to do an outline of every kind of thing I could be asked to do for that test. And I'm going to make sure that I can talk through where to go on the machine, what it's going to want, all that. I've got to be able to say my process out loud. Because if I can't say it out loud, there's no hope of doing it. So that's everything that we've covered so far that will be on your test in a couple of weeks. And now we're about to start chapter 8. Okay. Now, chapter 8 deals with hypothesis testing. Okay. All right. Now, this is the reason that most people end up doing statistics. Some statistics classes start here. Okay. Your class didn't start here because they didn't assume that you had a big background. All right. But this is the reason that a lot of people have to have statistics or they're studying statistics. Okay. Because they want to do hypothesis testing. So my job was to kind of get you to this point, kind of introduce you to the idea of hypothesis testing. Then your disciplines can take you forward. You can do research and read research and test things in your own discipline. Okay? Now let's talk about what a hypothesis is first. All right, what is a hypothesis? Now, if you like looking in your books, remember you're on chapter 8. All right, and it basically starts, let's see, around page 358. Now, all a hypothesis is a claim. All right, it's just a claim, like a statement about a population. So it's just a claim, it's a statement about a population. Okay. Now, what we're going to do is this. Today, all I'm going to do today is kind of get you set up. All right, because I've got about 30 minutes, which should be plenty of time. Okay. So what's going to happen is this. We're going to talk about set it up today. All right. Sunday, hopefully, if everything goes according to plan, you get an email from me that says, go watch this video before Tuesday. All right. So I'm going to set it up today. Then on the video, I'm going to do a hypothesis test. And when you come to class on Tuesday, or when you're on Zoom on Tuesday, I'm going to do it. In other words, we're going to do hypothesis testing about two different things. We're going to do it about proportion, and we're going to do it about mean. Kind of like normal curve and central limit. Central limit was normal curve with one more step. That's kind of the way it is with hypothesis testing with proportion and mean. The process is the same. So you're going to learn kind of to set them up today. You're going to watch the video, and the reason you're going to watch the video, Tuesday, I'm going to go pretty fast. So if you don't watch the video before Tuesday, chances are on Tuesday, I'm going to lose you. All right? Because what happens is, that's where your test material is going to stop. It's on hypothesis testing. Then Thursday, we're going to make sure that everybody's good and cleaned up on that. Is everybody with me? And I'm going to go ahead to correlation. But correlation is going to be on your final. Well, then the next week, that's the last week of class, mainly. So that Tuesday is when you'll have your test. Because I will see everybody that Thursday and that Tuesday. Is everybody with me? That way everybody's got a chance to look over their physical test. So on that Tuesday, you'll take your test. All right. Which means where will y'all be? Again, upstairs. Okay. So you'll take your test on Tuesday. On Thursday of that week, then we will go over your test and finish correlation. And then the next week, classes meet Monday and Tuesday, so that Tuesday we'll review. Now, I'm hoping I can review some on Thursday as well. Is everybody with me? I'm hoping I get a day and a half of just review. So hypothesis testing is going to go pretty quickly, but it's not hard. Okay? Again, guess what does a lot of the work? Calculator does. All right? But it is a little more set up for hypothesis testing. But to me, this is one of the most interesting things that we kind of do. All right. So a hypothesis is going to be a claim about something. Rachel?
Can you send us all those dates in an email?
What now?
Can you send us all the dates in an email?
Sure. But I mean, all you got to worry about basically is you take a test a week from Tuesday. The rest of it we'll just kind of do as we go. Okay? Now, what's going to happen is this. On a hypothesis, every time you do a problem, you're going to have two hypotheses. All right? You're going to have one called the null and one called the alternative. We'll talk about that in just a second. But here's what I want to kind of make sure you understand. All right. Hypothesis is a claim. Well, that claim is either true or what? Or false. So that's what the whole point is. The whole point of hypothesis testing is to figure out, is that claim true or is that claim false? Now, here's the deal. That claim is either true or that claim is false. Now, here's what's going to happen. You're either going to reject it. So you're going to have two jobs. at the end of the whole thing, you're either gonna reject the claim, or, now what do you think the next word's gonna be? Except, they don't phrase it that way. I'm gonna put failed to reject, and then I'll put except in parentheses to kind of explain something. But for right now, I want you to kind of think of it as reject or accept. And I'll talk about in a minute why they don't use that word. Okay. Now, I'm going to give you two different examples, all right, that are not kind of mathy, okay, because mathy tends to freak some of y'all out. All right, here's what I mean. Here's my hypothesis. And it's silly, but it helps people remember. My parachute will open. All right, I've always thought it would be super fun to go skydiving. One day I'm going to do it. At least I'm going to get on the plane. Okay. All right. When it actually comes time to jump, I'm a little, okay. So I get on the plane, I finally built up my courage, and I'm going to skydive. Okay, that's what I'm going to do for my birthday. That's my gift to myself. I'm going to skydive on this day. So the hypothesis is that that parachute's going to open. Now, that's really either what? True or what? Or false. Now, there's a couple of good decisions. If I'm standing in the plane, all right, and this statement really is true, and I believe it, and I jump, that's a good decision. That means that's the thrill of a lifetime. Is everybody with me? So the hypothesis was really true, and I accepted it. So do we understand that this would be a correct decision? Good job, Dr. Dean. How exciting. Now, what if this statement is false? So I'm standing in the plane, and they say, it's time to go, and all of a sudden I go, no, my parachute's not going to open. You know what I'm saying? Like, no, it's not going to open. I know it's not. All right? And it really will, and I get down to the ground, and they unpack it, and sure enough, that thing's tangled up, and I'm like, oh, I knew it. That would be another good choice on my part. So if this thing really is false, I don't want to accept it. What do I want to do? I want to what? Reject it. So this is another good choice on my part. This is the goal. We want to accept or believe true things and reject what? False things. Those are good choices. Now, these two would be mistakes. Your book calls them errors, but with vastly different consequences. So we agree that this is an error. That statement really is what? True. That parachute really is going to what? Open. But I'm standing in the plane and I go, no, I'm not, I don't believe it. Well, if I'm standing in the plane and I don't believe it, I'm not going to jump. So we get down to the ground and they unpack my chute and it's just fine. Like, my bad. But what's the end result on this error right here? That statement was true, but I didn't believe it. So the consequence is I missed the thrill of a lifetime. I wasted my $200 and there you go. But look at this mistake. That statement really is what? False. That parachute not going to open. But I'm standing in the plane, and what do I do to that statement? I what? I accept it. So I'm going to jump. What's the consequence there? Yeah, greasy spot. You see what I'm saying? Like, I die. Now, I think we can all agree that in this instant, this mistake is worse than what? Than that mistake. Death, loss of $200. Now, in your books, they talk about those two things, and I think they probably talk about them somewhere. I think they're on page 368 in yours. All right. So This one is called a type 1 error, and this one's called a type 2 error. Now, I don't expect you to remember that. It's just they label them, so they talk about a type 1 error means that the statement's true, but you reject it. A type 2 error means the statement was false, but you failed to reject it. Now, let me show you a different example, though. Here's another hypothesis. And this is the hypothesis on which the American court system is based. The person is innocent. All right, the person is innocent. Now, that's the American hypothesis in a court of law. So when that person, if I'm on the jury, when that person walks in, I'm supposed to assume that they are what? Innocent, not guilty, innocent. That means that the burden of proof is on the prosecutor. The prosecutor's job is to change my mind. All right. Now again, look, there are two correct decisions if I'm a juror. That statement is true. That person really is what? Innocent. And I accept it. I believe it. That's a good choice on my part. Then an innocent person goes free. That's what's supposed to happen. Well, this is another good choice if I'm a juror. That statement's really what? False. They're not innocent. And I'm sitting on the jury, and what do? I basically reject that statement. That person's not innocent. That's a correct decision on my part. A guilty person suffers. So that's the good decisions in a court. Innocent people go free, guilty people have a consequence. These two are mistakes if I'm a juror person. They're errors again. Now, look what happened before. Before, this one was the worst one, wasn't it? I was a greasy spot on the ground, I was dead. But look at the type 2 error in this situation. That statement's really what? False. That person's not innocent. But I'm on the jury, and what do I do with that statement? I what? I accept it. So if I believe they're innocent, are they going to get punished in any way? No. Well, that's an error. A guilty person goes free. That's a mistake. But in the American court system, we believe this is a worse mistake. Because look what this mistake is. That statement really is what? True. But I'm on the jury and I reject it. I'm not buying that they're innocent. So what's the consequence here? An innocent person what? Goes to jail or worse. Is everybody with me? So the American court system is set up purposefully so that this should happen more than this happens. That's the reason, that's the hypothesis. Okay? So what I want you to take away from that is this. In some situations, a type 2 error is worse, and in some situations, what? A type 1 error is worse. You have to decide in a real setting. Would I rather have more of these? Here's the other one that's true. The COVID test, when you get tested for antigens, you know, when you're tested for antibodies, it's not completely accurate. Matter of fact, it's not as accurate as I would like it to be. But it's purposefully picking the error. If it says that you have the antibodies, you have the antibodies. If it says you don't have the antibodies, so it would rather be a false negative than a false what? Positive. So the test is set up that way. It errs on, if you have the antibodies and you don't think you do, you're going to be careful. You know, all that matters is you're going to be a little more nervous. But they would much rather that be the case than you think you have them and you what? You don't. So once again, on that testing, if you have to skew it one way or the other, you got to decide which error is worse. And they're right. I don't want somebody who's running around with COVID, like infecting everybody, thinking that they're not. Everybody with me? So now, and on test, you won't have to decide. But what I want you to take away is there are 2 correct decisions and 2 errors. And in some situations, a type 1 error is worse, and in some situations, what? A type 2 error is worse. Now, What you're gonna do next is write down a whole bunch of steps. And then we're gonna do one or two. And then I'm gonna finish them on the video. All right, so when you're watching the video, you're gonna need to kind of have your notes out. Okay. Come back over here, get the jump back. All right. So I want you to write down hypothesis testing and start getting ready to list some steps. All right. We're going to write the steps down, all of them down, and then we're going to go do one. So it's going to kind of be a little weird at first. You're just going to be a scribe. All right. And I'll explain what all this means in just a second. All right. So hypothesis testing. All right, step one, you're going to change the claim to a mathematical sentence. It's going to be an English sentence, like a word problem. And you're going to turn it into a math equation or a math inequality. Okay, so you're going to change the claim to a mathematical sentence. Then you're going to write a second mathematical sentence that encompasses all the other possibilities. Okay. So the first thing you're going to do is take an English sentence and change it to a mathematical sentence. And then the next thing you're going to do is you're going to write a second mathematical sentence that encompasses all the other possibilities. And then you're going to label them, because every problem has two hypotheses. One is going to be called a null hypothesis, and one's going to be called an alternative hypothesis. So I'm going to label the hypotheses. The one that has equals in it is the null. That's the null hypothesis. And the other one's called the alternative. Okay. So the one that's got the equals in it is going to be called the null hypothesis. And then the other one is going to be called the alternative hypothesis. Okay. Now, step 4, this is real important. You always test the null. You don't necessarily test the claim. We'll talk about that in a minute. Okay, you'll see what I mean in just a second. You always test the null hypothesis. All right. So why do you need the alternative? The alternative hypothesis tells you which test to run. Okay. The alternative hypothesis tells which test to use. Now, this is not going to make much sense to you until you watch the video. You're just kind of doing a scribe right now. If it's got less than, you're going to use something called a left-tailed test. If it's got greater than, you're going to use something called a right-tailed test. And if it's got not equal to, you're going to use something called a two-tailed test. Okay. Step 6 is you're gonna find the significance level. And I'm gonna put in parentheses alpha, that's the Greek letter A. And they're just gonna tell you that. You're not gonna have to figure that out, they're just gonna tell you that. Then on step 7 is you're gonna use the calculator to compute P. And P is gonna be a probability. Okay, now, if it were me, I would skip a good bit of space. I'm not gonna skip it on the board because it depends on what you're testing as to where you go on the calculator. So if you leave yourself some space on that video, you can come fill in. Okay, so step 8, so I'm skipping a bunch of space. Step 8 is you're gonna compare P to alpha. So you're gonna have P in a box and you're gonna have alpha. So the probability is either going to be less than alpha, or the probability is going to be equal to alpha, or the probability is going to be greater than alpha. So you're going to put the correct symbol in that box. Okay? If P is less than alpha, you're going to reject the null. All right? If P is less than alpha, you're going to reject the null. Now, I'm going to put less than or equal to. I think your book puts less than or equal to. If P is bigger than alpha, you're going to fail to reject the null. And your last step is going to be, you're going to use basically a flow chart and write this answer in a sentence. Use a flow chart and write the answer in a sentence. Now you write all that down, and I'm going to illustrate what you're going to have to do for homework. It's pretty simple. Okay. I want you to look in your books on page 384 at number 16. Page 384, number 16. Okay. Now, I want you to read it silently to yourself just a second. So page 384, number 16. Because they're all going to be word problems. Okay, you got it? Now, go back and find where it says test the claim that and underline what follows. You'll always do that on the test or on your homework, with a pencil preferably if you got a book, if you got a book. Where does it say test the claim that and then underline what follows? So do you see it says use a 0.05 significance level to test the claim that less than 10% of the test results are wrong. That's what you have, that's what step 1 is. I need you to change that to a math sentence. Now, does it say anything about meaning? It doesn't, does it? So it doesn't have percent in what you underline. That means that you're going to be testing a claim about a proportion or a percentage. What symbol do we use? We use what? Isn't that P? Now, I'm going to remind you of this on the video, but when you're writing these hypotheses, always use population symbols. So I'm not using p hat, I'm using p. If it's mean, I'm not gonna use x bar, I'm gonna use mu. So p is, what does it say? Test the claim that the thing is what? Less, what's symbol for less than? But like that. And then it says 10%. Now don't p's have to be between 0 and 1. So I'm not gonna put 10, what am I gonna put? I'm gonna put 0.1. So do you understand what step 1 means about change the English sentence to a math thing? Now, put the word claim next to it so you don't get lost on the video. That, because you're gonna need that when you go read the flow chart at the end. Now, the number 2 says you need a second sentence that encompasses every other possibility. Okay? If the proportion's really not less than 1%, what's one sentence don't get me all the rest, then it must be what? Now, if I just put greater than, have I encompassed all the other possibilities, or have I left one off? What gets left off if I just put greater than? Equal. So it's got to be greater than or what? Equal. Because that, remember, it's got to be all the other possibilities. Does that make sense? Now, one of those is your null hypothesis, and one of those is your alternative hypothesis. How do I know which one is which? What does it say over there on step 3? How do you know which one's your null? What's it got to have in it? It's got to have equals. Which one of these has equals in it? The top one or the bottom? The bottom one. This is your null hypothesis, which means that must be your alternative. So your null is always the one that's got equals. It has to be just equals, but equals has to be part of it. Okay? Now, your book, I'm going to warn you, will put like H sub 0 and H sub 1 for null and alternative. I'm going to write the words so that it's not confusing. Now, so part of your homework, I'm going to give you several word problems that you have to do this too. Is everybody with me? You find where it says test the claim and you underline it. And then you change it to a math sentence, then you write down another one. The other thing you got to be able to do is tell me which test you're going to run. Now look back over here at number 5. Which one do I look at to decide which test to use? The null or the alternative? What does it say to look at? The alternative. Okay, look at your alternative. What does it say in there? Less than. So what am I going to use? Something called a what? Left tail test. You have no idea what that is yet, but you know it says over there on your steps, if the alternative has a less than, use a left tail test. And then it tells you that you have to find the significance level. So go back and read. What did it say your significance level was? It says use a what? 0.05. So my alpha is 0.05. So on your homework, I'm going to give you several word problems, and you're going to do the first 6 steps. So you're going to find where it says test the claim that, and you're going to underline it with a pencil. You're going to change that to a math sentence. Then you're going to write another sentence that encompasses all the other possibilities. What if I said that the probability was exactly 10%? Then it would have been P what? Equals what? 0.10. What would your other one have been then? P what? Doesn't equal. You see what I'm saying? So there's going to be 2 sentences. How do you know which one is the null? The one that's got the what in it? The equals. So you label them, you find the null, then the other one's your alternative. But which one tells you which test to run? It tells you in your steps the alternative does. If it's got less than, you run a left tail. To me, it was pointing to the left, so that's the way I would remember it. Greater than is a right tail, not equal to 2 tail. They're going to take you to significance level. So you can do your homework even before the video. Is everybody with me? But the video, I'm going to finish. I'm going to work a couple more like this, but I'm going to finish 1 or 2 out. So when you come in Tuesday and I start finishing them, you're a little bit familiar with what I'm doing. So homework's going to be where? On me. And then double check. When you get the email that goes, go look at the video. I'll tell you when it's ready. Have a great week.